Today, we're going to dive into a skill that honestly shapes pretty much everything, thinking in probabilities. It's all about mastering chance, but the real key to it, well, it's surprisingly hidden. So let's start with a really simple question to see if we can uncover it.
So let's kick things off with a question that seems almost too easy. If I roll a standard everyday die, what are the odds it lands on a 6? I bet most of us would just fire back 1 and 6 and not really think twice about it, right?
But what if I told you that simple answer hides a much, much deeper story? A story about how our brains are even wired to understand the world in the first place. Today, we're going to pull back the curtain on that complexity.
To do that, we've got to start with the basics. So, let's just break down this simple game of chance, and we'll use a fair, six-sided die. No tricks, no loaded dice, just straight-up odds.
You know, the act of rolling a die is what mathematicians call a random experiment. And what's so fascinating here is this balance between knowing and not knowing. We know everything that could happen, but we have absolutely no idea what will happen on any single roll. This predictable uncertainty, that's the playground where probability lives.
Now that set of all possible outcomes, it has a name, the sample space. For our die, the sample space is super simple, right? It's the numbers 1, 2, 3, 4, 5, and 6. That's it. Nothing else can happen. That set is the entire universe for our little experiment.
Okay, so we've got our experiment, we've got our sample space. Let's move on to the rules of the game. You know, how we actually figure out the odds.
And here it is. This is the core formula for simple probability. You just take the number of outcomes you're looking for, what we call the favorable outcomes, and you divide it by the total number of things that could possibly happen. Simple as that.
So if we apply that formula to our die, this is what we get. The chance of rolling a 1? Well, there's only one 1 on the die, out of 6 total sides. So that's 1/6. And the same logic goes for rolling a 2, a 3, a 4, and so on. Every single face has an equal 1 in 6 chance of showing up.
Now, here's a super important rule. If you add up the probabilities of every single possible thing that could happen, the total has to be 1, always. Why? Because it's 100% certain that one of those things is going to happen. Add 1/6 to itself 6 times, you get 6/6. That's 1. Certainty.
Okay, and this is where our whole story takes a really interesting turn. We've just walked through the math of probability, but what if getting good at this skill isn't really about the formula at all? What if it's about something totally different? It turns out there are two different but deeply connected ways of thinking happening here. On one side, you've got probabilistic thinking, all that stuff about randomness and sample spaces we just talked about. But on the other side, you've got proportional thinking, which is really just a gut-level understanding of fractions and ratios and how different amounts relate to each other. In fact, a lot of researchers argue that this second skill, proportional thinking, is the real foundation here. It's like the bedrock for probability, algebra, you name it. I mean, think about it. Understanding why a 1/6 chance is less likely than a 1/2 chance of flipping a coin isn't about some fancy probability rule. It's about just knowing that 1/6 is a smaller slice of the pie than 1/2. Without that intuition for proportions, probability can feel totally random and confusing.
So if this connection is for real, it might finally explain why so many of us find probability so tricky. Let's take a look at some actual data from a study that put this whole idea to the test.
So, back in 2013, a study looked right into this question. Researchers got 290 high school students and gave them 2 separate tests, one on probabilistic thinking and another one on proportional thinking.
First, let's look at how they did on the probability test. Out of a possible 21 points, the average student scored 12.355. Okay, so what does that number really tell us? Well, as this chart shows, the educationally acceptable level for this test was set at 12.6, which is basically a 60% score. The average score fell just a little bit below that. So, on the whole, students were finding probability pretty challenging. But the real shocker came from the second test.
So on the test for proportional thinking, that foundational skill with fractions and ratios, the average score was a striking 9.75 out of 21. This wasn't just low, it was way lower than how they did on the probability test.
And this really gets to the heart of what the study found. There was a direct, statistically proven link between these two skills. The students who had the hardest time with proportions were the same ones who had the hardest time with probability. If the foundation is shaky, the whole house is going to be unstable.
So what's the big takeaway for us? It means that really truly getting a handle on chance and randomness is about so much more than just memorizing a formula.
Let's just break down what this all means. For a lot of people, the struggle with probability actually starts with a shaky understanding of fractions and ratios. To really master chance, you need a strong, intuitive feel for how proportions work. It's not just about memorizing rules, it's about building a fundamental new way of thinking about how parts relate to a whole. And believe it or not, this isn't some new idea. This 2013 study was really standing on the shoulders of giants. Researchers are pointing this out way back in 1988, saying that the #1 reason students struggle with probability is that they have a hard time with rational numbers and proportions.
So that leaves us with one last big question to think about. Is getting better at understanding chance just a matter of memorizing some rules and formulas? Or is it something deeper, a process of actually rewiring our gut intuition about numbers, ratios, and how things relate to each other? Thanks for joining me for this explainer.